So for me, on exercise 2.14, for y equals g of x on the left, I notice that there's a few points that cross the grid at whole numbers. And so these 2 points give me a rise of 1 unit and a run of 2 units. And so I can see that throughout this entire line here, the slope of this linear function is 1/2. That means for all points here, the derivative is 1/2. So this is what my derivative function looks like for g prime of x. No matter what the x value is, the y value, which in this case is the slope, is equal to 1/2. Now on the function on the right, h of x, there's not a constant slope. This function's increasing, decreasing in many places. So first, I find the places where the derivative is 0. Those are those turning points, the peaks and valleys. It looks like at the x value of -3, the slope is 0. At the x value of -1, the slope is 0. Near the x value of 1, the slope is 0. And at the x value of 3, the slope is 0. In between, let's say, -3 and -1, in those x values, the function is decreasing. If the function's decreasing, that means those slopes are negative. So I'm going to make a negative part there. How far down it goes, it doesn't matter to me in this case. Between -1 and 1, the function h of x is increasing, so those slopes are positive. So I'm going to make a positive connection, make them above the x-axis. Between 1 and 3, those are decreasing again, so I'll put them below the x-axis. After 3, it's increasing, so after 3, slopes are above the x-axis. And I almost forgot, before -3, the function was increasing there, so those slopes are positive. So this is my rough answer to exercise 2.14. Next, I want to show you how to use the definition of the derivative to find the derivative of a function. So let me go to a new page here, and let me give you the definition of a derivative. The definition of the derivative function is f prime of x is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. That's the definition of the derivative function, f prime of x. La 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 la. There it is. So we can use this definition to find the derivative of a function like if f of x equals x squared, that parabola. What is f prime of x? We can use this definition of the derivative. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. And then I'll start to work on it. So f of x plus h, that's kind of hard. Let me save that for later. F of x, that's easier. F of x was x squared, so something minus x squared. F of x plus h, well, f of x says whatever the input is, we're going to square the input. So the input is x plus h, so I'll square that. Now some algebra. X plus h squared is going to be x plus h times x plus h, still minus x squared over h. X plus h times x plus h is x squared plus xh plus xh plus h squared minus x squared all over h, which gives me, let's see, oh, look at that. X squared and minus x squared, those are gone. So I have 2 of those xh things plus h squared all over h. And now I notice I can factor an h out of the numerator. So I get 2x plus h over h. And then I see that I can divide out those h's. So we get the limit as h goes to 0 of 2x plus h, which is 2x plus 0. As h goes to 0, this h goes to 0. As h goes to 0, nothing happens to 2x. And so I get 2x. That is my derivative function. And so what is f prime of x? F prime of x equals 2x in this case. And if we think back to the table we had earlier, negative 0.5, negative 1, 0, 0, and 1, 2, this table fits this rule where the derivative is 2 times the x value. That works if the function is x squared. If it's a different function, like you'll see in exercise 2.15, we have to do something different. So for exercise 2.15, 2.15, I'd like for you to practice using the definition of the derivative, doing this process here with those 3 different functions that we have.